Hello and welcome to the class on one-way analysis of variance. The student's t-test is used to compare only two groups. When we have to compare more than two treatment groups, as is the case of CRD, the use of student t-test becomes tedious. We will have to perform the comparison of each pair of means in every possible combination. Also, the probability of error will become enormous. The analysis of variance is the appropriate statistical technique to be used in situations where we have to compare more than two groups. One-way analysis of variance is simply an extension of the t-test. When there are multiple groups, the observed differences or the observed variation among the groups consists of two components: between the group's component of variance and within the group's component of variance. ANOVA separates the total variance into within and between components of variances. If between component of variance is greater than within component of variance, then the differences between the groups are said to be significant. Whereas if the between component of variance is less than within component of variance, then the differences between the groups are said to be non-significant. The skeleton of one-way ANOVA table is composed of various columns such as source of variation, degrees of freedom, sum of squares, mean sum of squares, expected mean squares, and F ratio, where B stands for between and W stands for within. Within the group's component of variance is estimated based on within the group's mean sum of squares, whereas between the group's component of variance is estimated based on between the group's component of mean sum of squares. In one-way ANOVA, we'll have to estimate various sum of squares such as total sum of squares, between the group's sum of squares, and within the group's sum of squares. At this stage, treat sum of squares as a measure of variation. If we look into the details of the formula of standard deviation, we can define standard deviation as root mean sum of squares. Variance, which is the square of standard deviation, can be defined as mean sum of squares. If we look at the numerator of the formula of variance, what we observe is nothing but sum of squares. If we divide the sum of squares with respective degrees of freedom, we are likely to get mean sum of squares, which are nothing but the components of variance. ANOVA is applied in a variety of experimental designs, such as completely randomized design, randomized block design, as well as factorial experiment. We can apply one-way analysis of variance in completely randomized design. This table represents generalized structure of a completely randomized design. The steps of one-way ANOVA in CRD includes setting up a null hypothesis, stating that there is no significant difference between the treatments. The basic calculations include calculation of treatment total, calculation of grand total, and calculation of correction factor. Next step includes calculation of sum of squares, total sum of squares, treatment sum of squares, and error sum of squares. One-way ANOVA table is constructed using the given columns. and F ratio is calculated by taking between the groups mean sum of squares divided by within the groups mean sum of squares. The initial decision will be based on comparison of calculated F value with the table F value. If calculated F value is less than the table F value, the differences between the treatments are said to be non-significant and therefore null hypothesis is failed to be rejected. Whereas if the calculated F value is greater than the table F value, then the differences between the treatments are said to be significant and therefore null hypothesis will be rejected. If null hypothesis is rejected, we need to calculate the critical difference value. Critical difference value is the minimum difference value which is to be considered for significance of difference between any two treatment means. Critical difference value is estimated with the help of given formula. And if the difference between any two treatment means is greater than the critical difference, then those two groups are said to differ significantly. Whereas the mean difference between any two given means is less than the critical difference, the given groups do not differ significantly. Thank you.